Okay, hello there. Welcome along to this extra kind of unit that we have at the end here. So we're going to be talking about improving our understanding and confidence when we're faced with these kind of bigger questions and the more kind of mixed topic questions in particular. So for these then, what we're going to look at really, we're going to try and break these down a little bit. We're going to look at what these bigger questions or these mixed questions are. We're then going to kind of have a bit of a brainstorm about, well, how is it that we can actually answer these, any kind of methods that we can use to make these a bit easier to tackle. And then we've got some level 1 examples and some level 2 examples. And then there are obviously assessments on the classroom that you can mark through. One thing that I will say very quickly is the assessments themselves here, if you're scoring even 25% in them, that's absolutely fine. The limitation of the Google Classroom is the fact that it will award all of the marks or none of the marks. And as we'll see with some of these questions, if they're maybe 6 marks, you're probably still going to be getting at least 2 or 3 of those marks. So the Google Classroom score is an underestimate of your ability, but it is getting used to these types of questions, which is going to be really useful. This is really where most learners struggle. It's, you know, this element of the functional skills, which is quite different from kind of previous maths that we might have done. Okay, so what are these questions then? All of the papers tend to follow a bit of a pattern. There is always going to be a large kind of 6-mark question, and it tends to be at the end of the non-calculator paper. Okay, it's more common with the level 2 papers, but it's quite a common kind of trend that we have this kind of 5, maybe 6-mark question at the end of the non-calculator paper. So that's something to bear in mind there. There will always be another 5 or 6-mark question in the calculator section as well. We can also see 1 or 2 of these 4 or 5-mark questions that kind of pop up as well. So we do have a bit of a mixture. 6 marks is the biggest question that they can ask. You're probably going to get 1 of them at least, and then there will be probably a few of these 4 or 5-mark questions as well. Now, the thing to be aware of here is, you know, just because a question has more marks assigned to it, it doesn't mean it's any more difficult. They have to award you marks dependent on the maths that you're doing. So it's probably just that there are quite a few steps to the problem. It's not that it's more difficult or harder, so to say. Okay. My advice to you then is for every question that is 4 marks or higher, what we should do is pause. Immediately, as soon as we see the question, we're going to look at the mark scheme and we're going to say, okay, well, as soon as you see it's 4, 5, or 6 marks, we're going to kind of pause. And then what we want to do is just take our time, okay? If you have no additional learning needs, so you don't have dyslexia or anything like this, then it actually works out for every mark on the paper, this is about 1.8 minutes. So if you're answering a 6-mark question, you've got over 10 minutes to do this. If you do have an additional learning need, such as dyslexia, dyscalculia, ADHD, then you'll get an extra 25% of the time as well. So that's an extra 2.5 minutes here. So you have got the time to pause for these. Read the question through fully and do not do the maths. Okay, so when the problem comes up, we're just going to pause. We're going to read the whole question. We're not going to start jumping in and doing bits. Sometimes the 4, 5, 6-mark questions, they are very linear. So it might just be that we do, okay, I can clearly see I'm going to do this, then this, and there's my answer. With that being said, some of them are not linear. And this is where people tend to kind of get a little bit stuck. They get pulled off track a little bit, and they're trying to remember what the next steps are and what they need to do next while they're doing the maths. And this is where people get a little bit confused. So trying to start solving the problem as we read it just does lead to more of these difficulties, as I mentioned. So the brain's trying to remember what the next steps are, and it's not focusing 100% on each of the tasks that we've got. The best thing that you can do is make a bulleted list or write down the steps that you need to do. Don't do the math, but write down what you need to do. Sometimes it can help working from the end of the question and working backwards. So you know what your final thing, your final kind of answer will be. It'll be, oh, well, is John correct? But to prove that, we need to know how much does it cost to work that out. We need to know how many items we have, and so on and so forth. Imagine if you're going shopping, for instance, you know, you always take a shopping list. It means it's a lot easier to remember all of these extra little parts. Breaking down a kind of a task like this just makes it so much easier. The idea of, I don't know, painting an entire house and all of the interior seems like a lot. If you break it down and you look at it as painting room by room, it seems more feasible and more achievable. If you think about it then of break it down to painting each wall at a time, then the task becomes very manageable. So by breaking these questions down into these digestible chunks, we can focus on kind of each thing one at a time, essentially. Okay, so we want to break these questions down. That's really the main thing here. But the other advantage for this is that we can get some extra marks, essentially. So even if we read through the question, maybe it has some circle formulas in it. And let's say we really rack our brains, but we can't remember how to get or how to apply the circle formula, or maybe we can't remember the circle formula. Now, what a lot of people do, as soon as they see the circle, they go, I can't do it, and they'll just skip the entire question. We don't want to be doing that. What we want to do is think, okay, well, I know that I need to work out the area of a circle here, and I need to apply it. If we've written out this bullet pointed list, it might be that maybe one of the parts we can't answer. What we can do is make up a number for it. We can just say area of the circle is 9. Why not? You're not going to get that mark. You're not going to get the full correct answer mark, but then you can use that, and it's you know, it might then be that whatever the size of a circle is, we need to multiply it by a cost or by something else. So you can then obviously keep working through. You can get a lot of the marks that would have been lost if you just skipped the question, essentially. So most of these larger marked questions tend to be based around area, volume, surface area, or density. So these kind of our area topic and our compound measures topic. We do find some of these linked around statistics and comparison of data. So these can be quite nice questions where they pop up and it will maybe say, you know, calculate the mean. And then from there, it's a case of, you know, so we want to calculate the mean, and then it will, maybe we have to calculate the range as well. And then the question will ask us about the consistency. And essentially we find a mean, we find a range, and then we just say this range is higher, this mean is lower, etc. We do get a few of these questions though where they are combined topics. So it might be that we have to maybe read a piece of data, draw a line of best fit, and then we have to calculate a percentage or something like this. So it might be a 4 or 5 step question. So that's where this topic is going to be really useful, because although the classroom is very good and it shows a lot of these individual topic-based questions from your exam, there will be exam questions where you might have to find a fraction of something and a percentage and then draw a bit of data. Okay, so it's just preparing as much as we can. Again, with all of these, the main thing that we want to do is we want to break these questions down. Another thing that I just want you to be aware of as well is there are a lot of these kind of questions where people might see it and they'll go, well, hang on, why have they told me how to calculate the volume of a triangular prism? I already know that. I'm expected to remember that. Sometimes they will give you information in the question because they cannot exceed 6 marks. So it might be that, you know, you're finding out the total surface area of an object maybe, and they tell you what the top and the bottom are. And you go, well, I could have worked that out. They're not trying to catch you out or trick you. It's just now limiting how much maths you have to do so they can keep within the perimeters of the question. Okay, let's have a little bit of a look and a little bit of a breakdown of some of these then. So what I would suggest doing is maybe pausing the recording at this point, having a look over this question, seeing how you can do, make your own list, and then we can obviously go through and look at it, or I can go through the answer afterwards. If you are just wanting to as well, the PowerPoint for this has all of these revealed as well. Okay, so probably have a quick pause now. That'd be the best thing. Okay, so what we've got here then is Steph wants to cover part of her garden with paving blocks. The diagram shows part of the garden she will cover with the blocks. The shape of this part of the garden has one line of symmetry. All corners are right angles. Paving blocks are sold in packs, and each pack will cover 10 meters squared, and the blocks can be cut and joined. Work out the number of packs that Steph will need to cover the garden. You must show your workings. Okay, there's a few bits in here. You must show your workings. It will always say this. We're always going to show our workings, because if we then don't get the full correct answer, we can still get some of the marks. So we're always going to do it anyway. So we can pretty much ignore that part as it is. You tend to see that there's quite a few bits of wording in here which will appear more frequently. And I'll highlight these in just a second. But essentially, if I want to break this question down, the first thing I'm going to do, as soon as I see a shape question like this, my first thought is always going to be, am I dealing with area, with volume, or with a perimeter? Now, the thing that gives this away is here we can see each pack covers 10 meters squared. That's a really useful bit of information because it tells us that we're dealing with a squared measurement, so we're finding an area. It also tells us that we want everything in meters. If I have a look there as well, I can see all my units are in meters, so I don't have to do any conversion. But this very quick process is what we want to do. Every time we see a sketch or a drawing like this, we want to think, are the units the same? And what am I finding? So to solve this problem, then what we're going to want to do is, and again, without doing the maths, I'm going to fill in any of the missing lengths. This is a compound shape, so I'm going to split that. I'm going to split it across here. So I have the top part and the bottom part. I'll find the area of the top, the area of the bottom, and then I will find the total area and use that to find out how many packs I need. So already we've broken this down a fair amount. So some of the information here that needs to be highlighted. So it says here about this having one line of symmetry. That will be straight down the middle, and it's just essentially telling you that this measure here will be the same as this one. That's all that's telling you. So line of symmetry, mirror line. It also says about all of the corners are right angles. They do use this wording quite frequently, and it's just them letting us very clearly know that we're going to be dealing or solving this problem with rectangles, essentially. Now, the other part to highlight is this, because it does pop up quite frequently, and it's the idea of the blocks can be cut and joined. And you'll see this as well, where maybe it's someone putting skirting boards around a room is one that they like to use as well. Blocks can be cut and joined. The boards can be cut and joined. All this means is we are the we're not the builder, we are the architect, essentially. We're saying, okay, well, this is what you need, but we're not actually building it. So we don't have to worry about going to the shop, cutting this down to the exact length and so on. So it just makes our maths a bit easier, essentially. Okay, so first of all, then we're going to fill in these missing lengths. So I know I've got 5 meters on the side here, 175 here, and then this top measure here is going to be the bottom length of 9, and I'm going to take away the 175 on this side, 175 there, and I get my 5.5 meters. So I've filled in my missing lengths. I'm then going to split my shape. So I'm going to draw a nice line across here, and I need to find the area of my smaller part. So this is going to be my 5.5 times 3. So here and here, and this is going to be the area of this rectangle. Area of the bottom part, okay, well, that's got a base length of 9 and a height of 5, so I'm going to multiply these together as well, get 45 there. Total area, let's put them together. So that's going to be 61.5. And then the final step here then is, well, how many packs do I need? And this is one of the things where, yes, we could count up in tens until we get to 61.5. And I'm sure most people are quite happy there to say, well, you're going to need a few more than 6. It's going to be 7 in total. The shortcut here, though, is just remembering it's, how many lots of it do I need? 10 times something is 61.5. So therefore, we can use our inverse function, our backwards calculations here, and we can say 61.5 divided by 10 will tell us exactly how many packs we need. We need to be realistic here as well. So this is the idea of logical rounding. If I need 6.15 packs, technically, if I was just doing pure maths and I were to round that to the nearest whole number, it'd be 6. But that means I'd have random bits missing from my floor. So what I'm going to do there is actually say, well, it's 6 and a bit, so I'm going to need to have 7 packs there. Okay, so if we move on then, let's have another look at one of these questions. We've got another level 1 example here before we move on to the level 2. And again, I can spot straight away it's a 4-mark question. So I'm just going to pause and read the question first of all. So Rio has a mobile car wash business and he has a tank of water in his van. The tank is in the shape of a cuboid, so I know that is a 3-dimensional rectangle, 0.9 by 0.9, and when the water is full, it is 0.4 deep. So again, what I would recommend for this type of question, if it's tricky, draw a picky. Just draw a little sketch of this, okay? Rio uses 45 litres of water to wash each car. 1 meter cubed will hold 1,000 litres. Rio thinks that there is enough water in a full tank to wash 8 cars. Is he correct? Okay, first, let's break it down then. Our first thing here, are all of our units correct? Well, I've got meters wide, meters long, meters in depth. And then my measurement here is in meters cubed. So my units are absolutely fine there. What I need to do is I'm going to have to find out the total volume of this tank. Then I'm going to work out and use my conversion point here to say, well, how many liters is that? And then finally, it'll be, well, how many liters do I need to wash 8 cars? Is there enough? Okay. So we often tend to find this final bit, and when it's talking about someone, it says, Rio thinks this. Is Rio correct? It doesn't really matter what Rio thinks, in all fairness. We're going to go through and solve it. But the fact that we get to comment at the end and say yes or no, he is or he isn't, is actually going to get us 1 extra mark. So it's quite a nice little addition there in the question. Okay, the solution here then, so we can see all of our units are the same. This is absolutely brilliant. So we don't need to convert them, and we can, first of all, we can find out our volume. So it's going to be 0.9, 0.9, 0.4, and we get a total volume of 0.324 there. What I would recommend, again, if it is tricky, draw a picky. Do a little bit of a sketch. You're not going to lose any marks. If anything, you can only gain marks from drawing a little bit of a sketch there. Okay, so we've got the volume then. We know that 1 meter cubed holds 1,000 liters. So again, they've given us a very good ratio to work with because we know what 1 is. Well, I want to know how much is in 0.324. So I know it's going to be under 500 liters. Use an estimate straight away. Or I know it's going to be less than 500 because that would be half of a meter. Now, the nice thing with this is we can just say, well, how many ones? So if we were to go upwards with this ratio and say, well, I've got 5 meters cubed, I'd times it by 5. If I had 6.8 meters cubed, I'd times it by 6.8. In this case, even if it's smaller, I'm just going to multiply by it because I'm saying how many ones are in 0.324. Well, when I multiply through by that, it's actually going to tell me that the liters that can be held are 324 there. So we know that we've got 324 liters. It's 45 liters per car. So what we're going to do here is say, well, 8 times 45 is going to be 360. So we need 360 liters. We only have 324. So no, Rio is not correct. And you can be really clear with this as well and just say 324 is less than 360. Okay, jumping on to some of our level 2 questions then. Again, we can see here straight away, it's a 6-mark question. So we're going to pause, we're going to read this question, and we're going to bullet point down what we need to know. So Takeshi is the manager of a laboratory. The table shows information about the number of tests done at the laboratory each day in April. Okay, so I've got number of tests 1 to 10 here, I've got 8 there. So immediately looking at this table, it's a very essentially, it's a very nasty table in terms of finding what I would assume straight away is going to be an estimated mean. Normally, you will get these extra additional 2 columns. They do not always have to give them to you, though. But I can straight away, because I can see this is between 1 and 10, this is between 11 and 20, I'm assuming that's where it's going to go. So Takeshi expects the mean number of tests to be, the mean number of tests done each day in May to be 12.5% greater than the estimated mean number of tests done in each day in April. The laboratory is open for 31 days in May. Each test brings in an income of £130 for the laboratory. Work out the expected income. Quite a lot in there, isn't it? Again, let's just break it down. We've got time here. We've got almost 11 minutes to answer this. You have got time to do this shopping list. If you can't do all of it, we're still going to get some of the marks there. Okay, so first of all, I need to know what is the estimated mean. That's what I'm going to have to find out. So I know that if I'm finding an estimated mean, first of all, I need to find my midpoint. Then I need to find the overall estimated mean there. So that's going to be my first bit. That's probably going to get me 3 of the marks here. So what is the number of tests in May then? So we've got the mean number and it's going to be 12.5% greater. So we're going to find this mean. We're going to multiply it by 12.5, well, 12.5% even. And then we've got finally, what is the income? So we know that it's, okay, we've got our 31 days there in May, and it's going to be £130 for each one here. So we're going to have to compare between these as well. Okay, so first of all, then we are going to fill in our table. So again, if you need any more information on this, have a look at the averages and statistics video, and it will talk to you about this idea of midpoints and kind of midpoint times frequency and why we do this. But essentially, all we're going to do here is find the midpoints of these test numbers. So I'm not going to go through the full breakdown of why we do this. This is in the averages and statistics video, but we're going to find our midpoints first. So between 1 and 10, well, again, don't get caught out here. Between 0 and 10, the midpoint would be 5. This is between 1 and 10. So if you're finding the midpoint, always use the mean. Okay, we're going to add those two numbers, divide by 2. You will always get the exact middle. So 1 plus 10 is 11, divided by 2, 5.5. Then I've got 15.5. And you can then just essentially follow the pattern, really, going up in tens. 25.5 and so on. So then I'm going to do my midpoint multiplied by my frequency, and that will tell me how many of the tests are running. So in this case here, I have got 495 tests that have been completed at this point. Okay, so the number of tests in May then. So what we're doing here then is we're saying, well, we've got 16.5 tests essentially per day. That's what we've worked out. How many tests on average are being done per day? So it's 16.5, and I know that there are 31 days in May. So I'm going to do 6.5, 16.5 even. I'm going to multiply that by 31, and that is going to be the amount of days in May. So at the minute, we're looking at 511.5. Now, there is actually one extra step here, which I think I've actually missed out in this PowerPoint, so I'll have to re-amend this. But it's the idea here of the number of tests done in May will be 12.5% greater. So it might be that, yeah, in this case, and you can find this kind of either way. So what we're going to want to do here, I'm just going to very quickly amend this while I can. So we need to include this part here. So you can see, even for me as a qualified maths teacher and tutor, these can be difficult questions. So I need to increase this amount, 511.5 by 12.5. Okay, so I've got 511.5. That is my 100%. So what I need to do now then is I need to find 12.5%. So first of all, I'm going to find 1%, which will be 5.115. That is equal to 1% there. 5.115. I'm going to multiply it by 12.5. So that tells me that 12.5, when I've multiplied through, I get 63.9375. So it's going to be an extra 63 tests that are going to be performed here. I'm going to round that off. I'm going to call it 64, but that is my 12.5% there. So it's an extra 64 tests that are going to be done there. So we know the total number of tests, it was going to be 511.5. We're going to have an extra 64 tests added on here. So, and again, we can use a bit of rounding here. They will accept a small range of answers. So I'm going to say, well, 512 tests and my 64 tests. So that's going to give me a total of 576 tests in total. Okay, so this is the total amount of tests that are going to be done here then. All I'm then going to do is to work out the amount this is going to bring in. I'm going to multiply by this 130 to get my total income there. Okay, so let's move on then. We'll have another look at our final kind of question here then. So we've got one more example here then. So we've got Dorothy reads an article about a talent show. The article states that 17,424 people applied to enter the show last year, and each person that applied was either a singer or a dancer. The ratio of the number of singers to the number of dancers was 3 to 5. This year, 19,500 people applied to enter the show, and 39% of these were singers. Dorothy thinks that at least 1,200 more singers applied to enter the show this year than last year. Again, quite a confusing one. Well, let's just break it down and see what we've got here. First of all, we need to know, well, how many singers entered last year. So that's going to be our first thing. So we can use our ratio there to work out how many people entered last year. What we can then work out is, well, how many people are going to enter this year? And we've got that idea there. So we know our next total and we've got our 39% there. And then it's going to be a comparison. So it's not too bad. It's quite a bit more of a straightforward question, but it's seeing a ratio and a percentage in one question can cause a bit of confusion. So the solution here then is we need to know, well, how many people entered last year? So it was 17,424, and then either a singer or a dancer. The ratio is a ratio of 3 to 5 there. So in total, I've got 5, 6, 7, 8. There are 8 parts to this ratio. Again, some of this information, if it is a little bit confusing, you might need to go back and have another look or a review of the ratio session, or maybe the averages and statistics session that we've just looked at. So in this case here, then there are 8 parts. So I'm going to do 17,424 divided by 8, 2,178. So that's going to be one part there. It is 3 parts that are singers. So I'm going to multiply that by 3. And I now know that last year there was 6,534 singers there. Okay, so what about this year then? Well, this year we know there are 19,500 people and 39% of them were singers. So I'm going to take my value, I'm going to divide it by 100 to find my 1%. Once I know 1, I can find anything. Okay, so 195 people, that's 1%. I multiply it by 39, then that is going to give me my 39%, which is 7,605. Now, the only kind of end part here then is that Dorothy thinks that at least 1,200 more singers have applied. So is this true? So if I subtract these values, or again, you can go from the smaller value and count up if you wanted to, but you will have a calculator for this question. All of these questions have been calculated, just so you're aware. So I'm going to look there. Okay, lo and behold, I've got 1,071. So my final point here is going to be, no, unfortunately, she is not correct. 1,071 is less than 1,200. Okay, there's a few examples there for you. I hope this has been useful. And some of those extra bits to remember is just really take your time, break these questions down. That's going to be the most beneficial. Do be aware that sometimes they might give you information that you could calculate, especially in some of these area and volume questions. The reason they have done that is because they can't allow you to do any more maths because it would extend the 6 marks. That is the limit of the maximum size question. And what we've looked at today, then, we've looked at our bigger style questions and our mixed questions and what these are. Giving you some useful hints and tips as to how to apply with these. And then we've had our level 1 and our level 2 examples. So the final part then is essentially go and have a go at those assessments, see how you get on. They do have the overall answers broken down on there for you as well. And that is everything from me. So I hope that's useful and all the best with the rest of your course there. Okay, toodaloo.